Sorry, we got to pause this for real quick. I hear some. All right, I'm back. Little disturbance. How do I get rid of this? Okay. Little disturbance on the hallway. We're doing sense of scale. Sense of scale right here. Okay. So here's what we got. Here is a recipe for making 4 pancakes. Okay, a recipe for making pancakes. Oh, the learning target. I can use proportions or ratios to solve real world problems. Right, Natasha? I can use proportions or ratios to solve real world problems. So here's a recipe for making 4 pancakes. We're going to use proportions and ratios to solve these problems. 6 tablespoons of flour, 1/4 pint milk, 1/4 pint water, 1 pinch of salt, and 1 egg. That's a recipe. That's not even a pancake. That's like a crepe. That'd be like one of those really thin pancakes, right? That's going to be a really thin pancake. Okay, this recipe makes 4 pancakes. 4 pancakes over here. You want to make 10 pancakes. How would you convert this recipe here to make it 10 pancakes? That's what we're going to think about today. How much flour would we need for 10 pancakes? All right, we're going to need to use a proportion or ratio. So let me break out my math machine over here. Let me turn it on because some math might need to get done here. Right now, 6 tablespoons of flour for 4 pancakes. 6 tablespoons of flour for 4 pancakes. Let me I want to annotate this, but I don't want to change what I've got. Oh, what the heck? My session expired. We're going to see if we can do this here. Okay. All right, now I can start to annotate this. So how much flour do I need? This is the recipe for 4 pancakes. I need 6 tablespoons of flour. So 6 tablespoons of flour for 4 pancakes. So I could write that as a proportion. Oh, I wanted to draw. No, I want a pen. Where's my pen? I want to mark up. Yeah, let me mark up with green here. Can I do that? Okay, there's my 6. There's my no, that's not what I wanted. I want to mark up text highlighter. Freehand highlighter. Okay, let me try again. Oh my goodness, that's a huge highlighter. Is there any way for me to make that a little bit skinnier? No. Sorry, I haven't done this in a while. Okay, it's been a while since I did all this. 6/4. So what does the 6 represent here? The 6 is how many tablespoons of flour I need for 4 pancakes. The 4 is how many pancakes 6 tablespoons of flour means. All right, I need an equivalent proportion, equivalent ratio. But how many pancakes? For 10 pancakes. So I'm going to need to put a 10 over here, and I want to know the number. I want to know this number up here. What would this number be? So I'm going to give it a variable called x. How would I solve this kind of problem right here? Do y'all remember a thing called cross multiplication? Does that sound familiar? Cross multiplication? I'm going to cross multiply, right? Cross multiply means I take this times this and set it equal to this times this, right? So what I end up having is 4 times x. It's just going to be 4x. 4 times x is just going to be 4 times x. Can't do anything more with that right now. Equals 6 times 10. 6 times 10, that's 60. 60. Okay, how am I going to solve this? Do you guys know how to solve a simple equation like this? Remember how to solve? Well, here is one way to solve a simple equation like this. I can go into y equals, right? And I have an equal sign here. So I'm going to make one side of my equal sign y1. That's 4x. 4x. All right, and I'm going to go down to my other side of my equal sign, 60. Put 60 in there. And then if I go second table, I want to find out where these two numbers are the same. Where these two numbers are the same, then the x is going to be my number. All right, so if I go down here, keep going, my numbers are getting bigger, right there, right there. When x is 15, my two numbers are the same. In other words, when x is 15, these two numbers these two things equal each other, right? Because 60 equals 60. That's 15 is the answer, which answers this question. If you're a little bit more old school, like Mr. Salt, you would do this algebraically. You would say, oh, I can divide by 4. If I divide by 4 there, then 4 divided by 4 just cancels. I got to divide by 4 here. I got to do 60 divided by 4. And if you don't know, 60 divided by 4 is 15, right? If you don't know, use your calculator for that one. 60 divided by 4, it's going to be 15. All right. So 15. I need 15 table. What does this mean? Can you tell me what that means? I need 15 something. All right. We're trying to answer the question, how much flour do you need? So what does this 15 mean in terms of flour? Hopefully you're thinking it means 15 tablespoons. 15 tablespoons, right? So somewhere in here, I got to write 15 tablespoons. 15 tablespoons. Looking for a color that will stand out. 15 tablespoons. TBLS. It's an abbreviation for tablespoons. All right. 15 tablespoons. Well, I'm not crazy about how big this markup is here. But okay, I'm going to get rid of all of this now because we don't need it for the next problem. All right.
How's it going, Mr. Salt?
It's going all right. It's going all right. All right. So next we're going to ask, how much milk do you need? How much milk do you need to get in here?
Oh, no.
Okay. How much milk do you need? Similar situation, right? It's 1/4 a pint of milk for 4 pancakes, right? So here's our setup. 1/4 a pint of milk. I got 1/4 over here. I got to write tiny. 1/4 over here for 6 pancakes, or 4 pancakes, sorry, for 4 pancakes. For 4 pancakes is going to be, this is my proportion, 1/4 a pint of milk for 4 pancakes equal to, we got to set up a new proportion. We want to do 10 pancakes now. All right, 10. And then again, this is the number we don't know, so we'll give it a variable, call it x. And now you're going to cross multiply, set these equal, and use one of those 2 techniques I just showed you to solve this problem. Pause the video, give it a try. All right, I'm back. Hopefully you paused me, and hopefully you gave this a try. Hopefully you remembered it's cross multiplication, right? We're going to multiply these 2 things together and multiply, no, I didn't want to do that. There we go. And multiply these 2 things together. And this might have given you a little bit of a hard time. 1/4 times 10. Some of you might struggle with that. Well, that's not too bad, right? Let me start out. 4 times x. What is that? That's just 4x, right? 4x is just 4 times x. All right, putting that 4 out of there says 4 multiplied by x. I don't know what x is yet. It's going to equal 1/4 times 10. Well, what is that? That's going to be, 10 over 4. 10 over 4. If I really wanted a number, I can go to my calculator and put in 10 over 4 in the calculator. It'll spit me out a decimal. 10 over 4 is 2.5. 2.5. So let me get my eraser. Let me just put 2.5 in there. All right. 2. Woo, that was big 2. 0.5. Yeah, my scale of 5. There we go. There's a decimal in there. What do I do next? Do you see it? I got my problem is I want to get x by itself. I want to know what x is. Well, I can go to the calculator. I can go into y equals. I can clear out that. Oh, actually 4x works in this situation. 4x. Down here, I want to put 2.5 in. 2.5. And I want to find out what will x equal to make those 2 things the same. I go to my table. What would x equal? Okay, I got to go down, 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 down. Where are these 2 numbers the same? Oh. This is one of those ones where I don't get a really nice answer because it's not a whole number. This is one you can fix this. You can press, let's see, what is it? If I press plus and I go by 0.25, I can actually maybe, no, I gotta go even deeper than that. So I'm not gonna, this is gonna be tough. It's gonna be tough. So somewhere around 0.5. 2 and 2.5 is getting pretty close. Somewhere between 0.5 and 0.75 is gonna be our answer. But it's gonna be difficult to make the calculator give us what we want here. We do plus, I'm gonna do plus 0.25 to see if I can find it. Somewhere in here, no, maybe 0.1 plus 0.1. Ooh, I'm coming close. So somewhere between 0.6 and 0.7 is going to be my answer. So let me just figure out what that's going to be. I'm going to do it the old-fashioned way. Sometimes, this is why I like the old-fashioned way, because it just works. 4 divided by 4. Why do I divide by 4 here? Because I want to get x by itself, which means these two things are going to cancel. 4 over 4 is going to be 1, which is going to make this x 1x, which is the same thing as x. If I divide by 4 over on this side of the equation, I got to divide by 4 on this side of the equation. So my answer is going to be 2.5 divided by 4. That is easier to find. 2.5 divided by 4 is 6.25, or 0.625. 0.625, yes. And if I wanted to turn that into a fraction, I can press math. I can go over the num. Oh, wait, where is it? Frac, right? Actually, math, frac. Enter. 5 over 8. 5 over 8 is my fraction. That 6.25 is the fraction 5 over 8, right? I can discover that by doing 5 divided by 8 and get that right there. Okay, so my answer can be 5. Ooh, no. I didn't like that. That's an ugly 5. 5 over 8. 5 over 8. So how much milk do we need? We need 5/8. What? 5/8. 5/8 a pint. 5/8 of a pint. Pint. If I had easier, I could do a little. There we go. 5/8 of a pint. All right, I'm gonna erase all this mess here. I don't need any of that. Okay. 5/8 of a pint of milk to make 10 pancakes. All right, you feeling that? You feeling how that works? All right, we're going to calculate prices of paint cans next. Calculate the prices of paint cans. The prices are proportional to the amount of paint in the can. All right, so we're working with proportions. A liter is $15. So what would 2.5 liters be? Think about that. Pause me. Think deep. See if you can solve this on your own. Maybe you can. Okay. If 1 liter is 15 pounds, then 2 liters would be double 15, right? That'd be $30. But this isn't 2 liters. This is 2.5 liters. So what I got to do here is I can just multiply 15 by 2.5 to find out what this is. 15 times 2.5 is $37.50. $37.50. All right. I think you can solve the rest of these on your own. All right. You might just take 15 times 0.75 to find out what this one is. 15 times 0.6 to find out what that one is. The only one that might throw you is this one right there. What is the amount of liters of this? Well, how would I find the price? I would take this, $15, times this to get this. So let's talk about that. 15 times a number I don't know, x, is going to be equal to $76.50. $76.50. Can you solve a problem like that? Pause me and see if you can. Yeah, it's still recording actually. So I'm going to put 15 here. Hopefully you unpause me. I'm going to put 15x over here. I'm going to put 76.5 over there. And I'm going to see, can I solve this easy with my calculator? Can I save it easy with my calculator? I'm going to find out where this equals 76.5. When does the y1 equal 76.5? Oh my gosh, 76. Am I going to find it? Ooh. Now, if my calculator wasn't on the 0.1s, I would never have found that. but I actually have a match right there. 5.1. Let me see if that works. If that works, then 15 times 5.1 will be my answer. 76.5. 76.5. Another easy way of doing this would be take 76.5 and divide by 15. Why would I divide by 15? Because you see that x, if I wanted to get that x by itself, I would have to divide by 15 on both sides of this equation. That cancels to become just plain old x. So all that goes away. Divide this by 15, and 76 divided by 15 becomes 5.1. 5.1 liters. 5.1 liters. All right. Okay. I think I'm going to let you go here. I think the video's long enough. And right here, we got a photograph. It's enlarged to make a poster. The photograph is 10 centimeters wide, 16 centimeters high. And the poster's been enlarged where now the new width is 25. So these two numbers are in proportion to each other. You've got to set up and solve for a proportion and solve for this length right here, this question mark. How would you solve that? All right. I'm going to let you think about that and do this kind of, maybe ask somebody in the classroom. Can any other student figure this out in the classroom? I want you, it might be hard. This might make you struggle a little bit. Have someone who thinks they know explain it and have them explain why they think it's that high. All right. What else? And the building on the poster is. The building on the poster is 30 centimeters tall. Is it possible to figure out how tall the building is on the photograph? Oh, that's a good question. Think about that. Is this photograph a real building? Could we use this to figure out if we knew the width of the real building? Could we figure out the height of the real building? Think about that. And I'm Mr. Soul, and I'll see you in class.